Hello everyone. Good evening to respected Dr. Khushbu ma'am, our well-known keynote speaker, Dr. Paresh Patel sir, beloved lecturers and dear students. A warm welcome to you on this webinar. On behalf of KBS and Natraj College, I, Rutanshi Patel, lecturer in Chemistry Department at KBS College, heartily welcomes you all for today's webinar on symmetry and group theory in chemistry and its applications. The basic objective of this webinar is to provide expertise knowledge about the subject, and I'm honored to tell you that more than 12 colleges have been participated in this webinar. Thank you all for taking time out and participating in this webinar. Now, I would like to request Mr. Abhishek Patel, teaching assistant at chemistry department in KBS College, to take the opportunity to introduce our guest of honor, Dr. Paresh Patel, sir. Over to you, Abhishek, sir.
Thank you, ma'am. It's a great honor and matter of pride to introduce our eminent keynote speaker, Dr. Paresh S. Patel. Dr. Paresh has been working at the Post-Graduation Department of Chemistry, Veer Narmad, South Gujarat University, Surat. He has pursued his MSc and PhD in organic chemistry with a wealth of a teaching experience spanning 25 years at graduate and postgraduate levels. He has command over many topics like reaction mechanism, pericyclic reaction, photochemistry, molecular symmetry, and many more. He has published about 55 research papers in various reputed national and international journals. Dr. Paresh is currently supervising 4 research scholars, and under his valuable guidance, 9 candidates have completed their PhD. He has served as an investigator of a major research project funded by the University Grant Commission, India. Sir is serving as a life member of Indian Chemical Society and Indian Council of Chemists. Dr. Paresh Patel is also a board member of School of Science at PP Savani University, Surat, Veer Narmad South Gujarat University, Surat, and Vanita Vishram Women's University, Surat. On a final note, he is also a fascinating individual and we are grateful for his presence. Thank you, sir. Over to you, ma'am.
Thank you so much, Abhishek sir, for your wonderful words. Now, I would like to request Dr. Khushbu Desai to address our speaker on this occasion of webinar. Over to you, ma'am.
Thank you, Rutanshi ma'am. Good evening, everyone. Good evening, respected Dr. Paresh Patel sir. I especially thank you, Dr. Paresh Patel sir, for being associated with us for such a wonderful webinar and giving on the ignition to the students with the vast knowledge and sharing your experience with our students. I also welcome all the participants and I also thanks all the participants to participate and all the college faculties to participate in this webinar. Thank you all. Thank you very much. Over to you, ma'am.
Thank you so much, Dr. Khushbu ma'am. Now, uh, uh, I would like to request Dr. Paresh Patel sir to address our students and shower them with his knowledge. Over to you, sir.
Thank you for so good evening, all of you. So thank you, the patron of this webinar, respected principals, Dr. Punam Chavan, madam, convener of this webinar, Dr. Khushbu Desai, madam, and organizer secretary Rutansi, madam, as well as Abhishek sir. And thank you very much for nice introductions. So first of all, I would like to thank the patron as well as principals of this college to give me the platform to share my views against the students. So good evening, all of you. So dear students, today we are going for the one unit in inorganic chemistry, and the name of this topic is symmetry and group theory in chemistry and its applications. So before starting this topic, I would like to say something General introduction of molecular symmetry. Now we know that the correspondence of a figure with reference to plane, line, or point of a symmetry. Most of the nature, the beautiful things of the nature is due to the symmetry. We know that sun, moon, rocks, these are the beautiful natural things, and the beauty of that nature is due to the symmetry. And this type of this symmetry arise also in our molecules, that is known as molecular symmetry. So molecular symmetry, the correspondence of a figure with reference to plane, line, or point of a symmetry. Now in case of the water molecules, if you rotate these molecules along this axis around 180, so what will happen? Suppose this one is 1 and 2, H2 and H1. In case of the water molecule, this is the imaginary axis. And with the help of this imaginary axis, if we rotate these molecules along this axis around 180 to get the equivalent orientation position. So this about the symmetry is known as proper axis of symmetry. Now, symmetry elements and symmetry operation. These are the two important words in the molecular symmetry. Now, plane, line, or point, and point. These are known as a symmetry elements. And the process is carried out on plane, line, and point to get the equivalent orientation position. So that process can be recognized as symmetry operations. Now, first symmetry element is identity. It can be represented by capital E. E means antigen, means each and every molecule consists identity symmetry operation elements. And if we go for the identity symmetry operation, molecule remains as it is. There is no change in the molecules. As for example, identity, if you operate identity symmetry operation on water molecule, so there is no change in the position of the molecule. So this is known as a identity symmetry elements as well as symmetry operations. Second symmetry elements is proper axis of rotation. This can be represented as a Cn, and symmetry operation can be represented as Cnk. Now, what is axis of symmetry or proper axis of rotation? We have to image a axis, and with the help of that axis, if we rotate that molecule along this imaginary axis to get the equivalent orientation position, is known as proper axis of rotation or axis of symmetry. Now, n represents order of axis and k represents numbers of time that symmetry operations. Okay, here n is equal to 360 by theta, and k represents number of times that symmetry operations. First molecule is water molecule. If you rotate these molecules along this imaginary axis around 180 to get the equivalent orientation position. So here n is equal to 360 by 180 is equal to 2. And this symmetry operation can be represented as C21. Similarly, if you go for the 180 rotation again to give original molecule, and this symmetry operation can be represented as CT2. 2 means order of axis for water molecule is equal to 2. And C21, C22, these are the symmetry operations. So in case of the water molecule, C2 is a symmetry element and C21, C22 are the symmetry operations. In case of ammonia molecule, this one is the imaginary axis. The shape of the ammonia molecule is pyramidal. If you rotate this molecule along this imaginary axis, and if you rotate these molecules around 120 to get the equivalent orientation position. So what will happen? 1, 2, and 3. So this symmetry operation. Okay, first of all, the order of axis n is equal to 360 by theta is equal to 360 by 120 is equal to 3. So order of axis in case of ammonia molecule is 3. So this symmetry operation can be represented as C31. Similarly, C32, C33, C34, C33, these are the symmetry operations. So ammonia molecule consists C3 symmetry elements as a, and C31, C32, C33, these are the symmetry operations. In case of cyclobutane, this one is the imaginary axis. And with the help of this imaginary axis, if you rotate this cyclobutane molecule around 90 to give equivalent orientation position, suppose this one is 1, 2, 3, and 4. So 1, 2, 3, and 4. Okay, so in case of the cyclobutane molecule, if you rotate this molecule along this imaginary axis around 90 to get the equivalent orientation position. So this for cyclobutane n is equal to 360 by 90 is equal to 4. So order of axis for the cyclobutane molecule is equal to 4. So this symmetry operation can be represented as C41. Similarly, C42, C43, etc. In case of this is cyclobutadiene or cyclobutane. Cyclobutane. Now, in case of the cyclobutane, this one is the imaginary axis, and with the help of this imaginary axis, if you rotate this molecule along this axis around 72 to get the equivalent orientation position. Suppose this one is 1, 2, 3, 4, and 5. One, 2, 3, 4, 5. So here order of axis n is equal to 360 by 90, 72 is equal to 5. So order of axis in case of the cyclobutane or cyclobutadiene is 5. So this symmetry operation can be represented as C51. So different symmetry operations C51, C52, C53, C54, C55, these are the different symmetry operations. In case of the benzene molecule, this is the imaginary axis. And with the help of this imaginary axis, if you rotate this molecules along this imaginary axis around 60 to get the equivalent orientation position. Suppose this one is 1, 2, 3, 4, 5, 6. One, 2, 3, 4, 5, 6. So here order of axis n is equal to 360 by 60 is equal to 6. So this symmetry operation can be represented as C61. Now in case of benzene molecule, if you rotate this molecule along this imaginary axis around 60 to get the equivalent orientation position. If we rotate these molecules along this axis around 180 to get the equivalent orientation position. Similarly, these are the another C2s. It means in case of the benzene molecule, C6 is present as well as 6 C2s are present. Now, in this case, which one is the main principal axis? So, according to the rules and regulations of the molecular symmetry, higher order proceed first. It means with the comparison of C6 and C2, C6 can be considered as a main principal axis. So, in case of the benzene molecule, one principal axis C6 and 6 C2s are parallel to main principal axis. In case of BF3 molecule, this molecule is a planar molecule and this one is the imaginary axis. If we rotate this molecule along this axis around 120 to give equivalent orientation position. Similarly, if we rotate these molecules along this axis around 180 to get the equivalent orientation position. This is again 180. This is again 180. It means in case of the BF3 molecule, if we rotate these molecules along the BF bond around 180 to get the equivalent orientation position. So in case of the BF3 molecule, C3 is present as well as C3 is perpendicular to 3C2. So in case of the order of axis of C3 is higher than C2, so C3 is the main principal axis. So that symmetry operations can be represented as C3 plus, C3 minus, or C31, C32, and C33. Now, 3 C2s are perpendicular to the main principal axis C3. In case of alene molecule, this is alene molecule, this is optically active. Now, if you rotate these molecules along this axis around 180 to get the equivalent rotation position, this is another C2. Or if you rotate these molecules along this axis around 180 to get the equivalent rotation position, and this one is the third C2. It means alene molecule consists C2 and C2 is perpendicular to 2 C2s. Now here, order of axis of all the axes are the same. It means which one is the main principal axis. So according to the rules, the axis passes to the maximum numbers of the atom that can be considered as a main principal axis. So this can be considered as a main principal axis. And in case of C2s, these are the perpendiculars to the main principal axis. So C2 is the main principal axis and two C2s are perpendicular to main principal axis. So in all these are the proper axis of symmetry, or we can say axis of rotation, proper axis of rotation or axis of symmetry. So third symmetry element is plane of symmetry. Plane of symmetry can be represented by sigma. Now, what is plane of symmetry? We have to image a plane, and with the help of the plane, we have to bisect the molecule in such a way that one part is a mirror image of the another part of the molecule. As for example, water molecule, we have to image a mirror, and with the help of this mirror, if you uh, we have to consider this plane or mirror, and with the help of this mirror, which can bisect the molecule in such a way that one part is the mirror image of the another part of the molecules. Now, plane of symmetry can be classified into three categories. First one is vertical plane of symmetry. and that can be represented by sigma b. Now, what is vertical plane of symmetry? If plane is parallel to main principal axis, so that type of plane of symmetry can be recognized as vertical plane of symmetry. In case of water molecule consists two planes. In case of vertical planes, if plane is parallel to the main principal axis, so this type of the plane of symmetry can be recognized as a vertical plane of symmetry. Now, in case of water molecule, this is z axis, this is x axis, this is y axis. Now, in this case, this is parallel to x and this is parallel to z. So this plane can be recognized as a sigma b xz plane. In this case, this is parallel to z and this is parallel to y. It means this plane can be recognized as sigma b yz plane. So water molecule consists two vertical planes. One is sigma b xz plane and second one is sigma b yz plane. Both planes are parallel to main principal axis. So these are the examples of vertical plane of symmetry. Now, in case of if we operate sigma v xz symmetry operation, so there is no change in the position of the hydrogen atoms. If we operate sigma v xz, then what will happen? There is no change in the position of hydrogens. Why? This is molecular plane. So there is no change in the position of the hydrogen. But if we operate sigma Vyz, which can bisect the molecule, so to change the position of the hydrogens. So this is known as a sigma Yz symmetry operation. Ammonia molecule. This is the pyramidal shape of ammonia molecule, and ammonia molecule consists three vertical planes. Why? All the three planes are parallel to main principal axis. This one is the principal axis, and this is sigma Va, sigma Vb, and sigma Vc. All the three planes are parallel to main principal axis. So this type of the plane of symmetry can be recognized as vertical plane of symmetry. Second one is horizontal plane of symmetry. Now, what is horizontal plane of symmetry? If plane is perpendicular to the main principal axis, so that type of the plane of symmetry can be recognized as horizontal plane of symmetry. In case of BF3 molecule, this is planar molecule, and this one is the main principal axis. So here, this plane is perpendicular to the main principal axis. So this type of the plane of symmetry can be recognized as horizontal plane of symmetry, and this can be designated by sigma h. Now, if we operate sigma h symmetry operation, suppose this one is 1, 2, and 3. If you put a mirror over here, so there is no change in the position of all the three boron fluorine atoms, bonds. So F1, F2, and F3. So by operating sigma h, the position of molecule remains as it is. There is no change in the molecule, position of the molecule. Now, third type of the plane of symmetry is dihedral plane or diagonal plane of symmetry. So C is the dihedral or diagonal plane of symmetry. Now, what is diagonal or dihedral plane of symmetry? As for example, this is alene molecule. In case of the allyl molecule, this one is the main principal axis, and this is the C2. Now, what is dihedral plane of symmetry? This type of the plane which can bisect the main principal axis and C2 in such a way that one part is the mirror image of the another part of the molecule. Okay, this is the main principal axis and this is C2. Now dihedral plane which can bisect the main principal axis and C2 in such a way that one part is the mirror image of the another part of the molecule. So this type of the plane of symmetry can be recognized as dihedral or diagonal plane of symmetry. Now fourth type of the symmetry element is improper axis of rotation, improper axis of rotation or rotational reflection axis of symmetry, and this can be represented by Sn. Now Snk symmetry operation can be represented as Cnk plus sigma h. Now, what is improper axis of rotation or rotation reflection axis of symmetry? First of all, if we rotate any molecule around theta and reflection through horizontal plane to get the equivalent orientation position is known as improper axis of rotation or improper axis of symmetry and rotational reflection axis of symmetry. As for example, if you go for the PF5 molecule, in case of the PF5 molecule, this one is the imaginary axis, and this plane is perpendicular to the main principal axis. Now, if you rotate this molecule around 120, suppose this one is 1, 2, 3, 4, and 5. One, two, three, 4 and 5 remains as it is. And then if you operate sigma h to give F3, F1, F2, F5, and F6. So this process can be recognized as S31. Why S31? Here order of axis is equal to 3. Why? 360 divided by 120 means order of axis is equal to 3. So first rotation followed by the reflection, it means this can be recognized as an improper axis of symmetry or improper axis of rotation. Last symmetry element is the center of symmetry or point of symmetry. Now, what is point of symmetry? This is the imaginary point, and with the help of the imaginary point or center, which can intensify each and every atoms of the molecules. As for example, trans-dichloroethylene. In the trans-dichloroethylene, this is the imaginary point, and with the help of this imaginary point, we can intensify each atom of this molecule. So this type of the symmetry can be recognized as center of symmetry or point of a symmetry. So these are the symmetry elements and symmetry operation of organic molecules as well as inorganic molecules. Now, most important title in this symmetry is point group. So what is point group? This is the point, or we can say the collection of all symmetry elements and that related the symmetry operation which meet a point that is known as a point group. And according to the Soin-Flies method, how to find out the point group of any molecule? So we have to go for the many questions. So first of all, we have to go for the, is a molecule linear? If yes, then we have to go for the C infinite V and D infinite H point groups. C infinite V or D infinite H point group. Now, no. Then we have to go for the another equation. Here, sigma V is present. Then C infinite V point group is present. Sigma H is present. Then D infinite H point group may be present. Now, if no, then we have to go for another equation. Is any multiple higher order axis? Then we have to go for the two options, yes and no. If yes, then TD and OH point group may be present. If no, then we have to make a questions. Any proper, improper axis. Then we have to make a answer, yes or no. No and yes. If no, then C1, Ci or Cs point group may be present. If yes, then we have to make a question. Cn is perpendicular to NC2. If yes and no, then we have to go for the Dn, Dnh, Dnd and Dnv. No, then we have to go for the Cn, Cnh, Cnv and Cnv. Okay. So how to find out the, or how to assign a point group to the molecule? So first of all, we have to go for the molecule is linear or non-linear. If linear, then we have to go for the C infinite V or D infinite OH point group. If sigma V is present, then point group is C infinite V. Sigma H is present, then point group is D infinite H. Now, if molecule is non-linear, then we have to go for the another question. Is any multiple harder axis are present? If yes, then TD or OH point group may be present. No, then we have to make a question. Any proper improper axis are there? Yes. Then we have to go for the Cl is perpendicular to NC2. Just a minute. Here we have to assign as a proper as well as improper. Then Sn. Improper we have to make a question. Cn is perpendicular to NC2. If yes, then Dn, Dnh, Dnv and Dnv. No, then Cn, Cnh, Cnv and Cnv point group may be present. Okay. So let us start with the one examples. This is hydrogen. Okay, we know that hydrogen is a linear. Hydrogen is a linear. Means C infinite V or D infinite H point group may be present. Here, this plane is perpendicular to the main principal axis. It means sigma H is present. It means point group is D infinite H. Now, second example is the carbon dioxide molecule. Second molecule is carbon dioxide. This is the imaginary axis, and carbon dioxide is a linear. It means C infinite V or D infinite S point group may be present. Here, this plane is perpendicular to the main principal axis. It means sigma H is present, so point group is D infinite H. Another molecule is hydrochloric acid. In hydrochloric acid, this one is the imaginary axis, and with the help of this axis, if you rotate this molecule along this axis around infinite to give the equilibrium position. But here, this main principal axis is parallel to main principal axis. It means point group is C infinite H. Next molecule is methane molecule. Okay, we know that shape of methane molecule is tetrahedral. So this molecule consists E 4C3 sigma D and etc. So what is the meaning of multiple hydrogen? Okay, this is non-linear. It means C infinite V, D infinite H point groups are absent. And is any multiple hydrogen axis? Yes. Now what is the meaning of multiple higher order? Okay, minimum order of axis is 3 and minimum multiple is 3. It means 3C3 is the minimum criteria to be a higher order axis. So methane molecule consists higher multiple higher order axis. It means TD or OH point group may be present. If sigma D is present, then point group is TD. And if sigma H is present, then point group is OH. Or the shape of this molecule is tetrahedral, so that molecules can assign a sigma D, TD point group, and if octahedral, so OH point group is present. Another molecule is SF6 molecule. This molecule is octahedral. This molecule consists E 3C4 sigma H etc. symmetry elements. Okay, so this molecule is non-linear, means C infinite V, D infinite H point groups are absent. Now 3C4, it means this molecule also consists multiple harder axes. It means TD or OH point groups may be present. But the shape of this molecule is octahedral as well as sigma H is present. It means OH point group is present. Another example is hypochlorous acid. This is the shape of hypochlorous acid. This is planar molecule. Now, this is non-linear. It means C infinite V or D infinite H point groups are absent. Any multiple order, there is no proper improper axis are present in the hypochlorous acid. It means we have to go for the no, it means C1, Ci or Cs. Then we have to make a questions that I is present, it means point of symmetry is present, no. Then we have to go for the is it planar? Yes. This molecule is a planar. So CS point group can be assigned. CXYZ. This is the ZW. This is the substituted methane derivatives. In this one, all the groups are different. So here non-linear, multiple harder axis, any proper and proper and improper axis are also option. So we have to go for the I is option, S is also option, means point group is C1. Next molecule is, this is known as difluoroethane. Okay, now this is non-linear. Multiple harder axes are also option, and proper improper axes are also option. Means point group may be C1, Ci, or Cs. But this is not a planar, and here I is present. It means point group is Ci. Next molecule is water molecule. Water molecule consists E C2 sigma Vx and sigma Vy. Okay, so according to our topic, we have to remember the symmetry elements of water molecule as well as symmetry elements of ammonia molecule. Okay, is it non-linear? Is a molecule non-linear, linear or non-linear? This is non-linear. Multiple harder axes are also option. Only one C2 is there. So any proper, yes, proper axis. So C2 is perpendicular to two C2s. No, C2 doesn't perpendicular to two C2s. It means we have to go for the C option. Here, order of axis is equal to 2. It means C2, C2H, C2V, or C2D. But here, two vertical planes are present. It means point group is C2V. Point group is C2V. Another molecule is ammonia molecule. Ammonia molecule consists A, C3 plus, C3 minus, and 3 sigma V. 3 sigma V means sigma Va, sigma Vb, and sigma Vc. Okay, this is non-linear. Multiple harder axes are option. Why? Here only two C2s are present, two C3s are present. Proper axis, yes, proper axis are present. But here C3 doesn't perpendicular to three C2s. It means we have to go for the C option. Order of axis is equal to 3. It means C3, C3H, C3V, or C3D point group may be present. But here 3 sigma V are present. It means point group is C3V. Another molecule is VF3 molecule. This molecule consists E C3 plus C3 minus and perpendicular to 3 C2s and sigma H is present. Okay, this molecule is a non-linear. Multiple harder axes are also absent. Proper improper, yes, proper axis is there. So here C3 is perpendicular to 3 C2s. It means we have to go for the D option. So n is equal to 3. It means D3, D3H, D3V, or D3D point group may be present. But here sigma H is present. It means point group is D3H. Benzene molecule. In case of benzene molecule, it consists E C6 plus C6 minus, or we can say C6, and C6 is perpendicular to 6 C2s and sigma H. So this is non-linear. Multiple harder axes are absent. Proper improper axis, yes, there is a proper axis. But here C6 is perpendicular to 6 C2s, so we have to go for the D option. And in D option, sigma H is present. It means point group is D6H. And last molecule is alene molecule. Symmetry elements C2, C2 is perpendicular to two C2s and sigma D. In alene molecule is a non-linear. Multiple hardware axes are also option, but here C2 is perpendicular to two C2s, means you have to go for the D option, and in D option D6, D2, D2H, D2V or D2D. Why? The order of axis in case of the alene molecule is 2. But here C2 is perpendicular to 2C2 and sigma D is present. It means point group is D2D. Okay, so I think this is the enough general introduction regarding the molecular symmetry. Now we are going for our main title of our syllabus, that is matrix. First title of our unit or topic is the matrix. Now what is matrix? Matrix is a combination of numbers arranged in a rectangle array and combined with another matrix following a definite way. So matrix can be represented as combination of numbers, just like a11, a12, a13, and so on, a1n, a1, a21, a22, a23, and so on, a2n, a31, a32, a33, and so on, a3n. Similarly, we can go for the AM1, AM2, AM3, and so on, AMN. So matrix is a combination of numbers which can arrange as a rectangle array in form of numbers of the rows and numbers of the column, or we can say matrix can be represented by m cross n. M is equal to numbers of the row and represents numbers of the column. So matrix can be represented as numbers of combination of the numbers which can arrange in a rectangle array as a in form of the numbers of the rows and numbers of the columns. A is equal to 2014. Okay, here number of the rows is equal to 2, numbers of the column is also 2. So this matrix can be represented as a 2 by 2 matrix. B is equal to 415036. Okay, here number of the rows is equal to 3 and numbers of the columns is equal to 2. So this matrix can be represented as 3 by 2 matrix. Now summation and subtraction of a matrix. A is equal to B is equal to okay, summation and subtraction of any two matrices is possible if the dimension of the both these matrices are the same. Okay, now this is 3 by 3 dimension matrix. This is also 3 by 3 matrix. It means summation can be possible is equal to 4 plus 1, 5 plus 3, 6 plus 2, 7 plus 0, 9 plus 4, 3 plus 1, 4 plus 2, 5 plus 1, 2 plus 2. is equal to, we can say that 5, 8, 8, 7, 13, 4, 6, 6, 4. Okay, so this is summation of two matrices. Now subtraction, A minus B. Subtraction can be represented as minus, 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 to give 3, 2, 4, 7, 5, 2, 2, 4, 0. So this is the subsection of two matrices. Now next one is combination or multiplication. Combination or multiplication of any two matrices is possible if the numbers of the rows of the first matrix and is equal to numbers of the column of the second matrix, or number of the column of the first matrix is equal to the numbers of the rows of the second matrix. Then and then combination or multiplication is possible. As for example, A is equal to 2, 1, 3, 1, 2, 1. B is equal to 3, 1, 2, 4, 5, 2. Okay, here the number of the rows of the first matrix is equal to 2 and numbers of the column is equal to 2. Number of the rows of the first matrix is equal to numbers of the column of the second matrix, or number of the column of the first matrix is equal to numbers of the rows of the second matrix. Then and then combination or multiplication is possible. So here combination or multiplication is possible if you go for the A cross B. Then what will happen? So we have to go for the first row and first column, just like this one, first row and first column. So 2 by 3 plus 1 by 2 plus 3 by 5. First row, second column, so 2 by 1 plus 1 by 4 plus 3 by 2. Then second row, first column, 1 into 3 plus 2 into 2 plus 1 into 5. Second row, second column, 1 into 1 plus 2 into 4 plus 1 into 2. So is equal to 6 plus 2 plus 15. Here 2 plus 4 plus 6. 3 plus 4 plus 5. 1 plus 8 plus 2. So is equal to 23, 12, 12 and 11. So this is the combination or multiplication of any two matrices. Next one is determinant of this matrix. Now how to find out the determinant of this matrix? That can be represented as a determinant of this matrix. Now, determinant for the two-dimensional matrix and three-dimensional matrix, both are the different. A is equal to 6, 4, 2, 3. So in case of the two-dimensional matrix, combination of this can be recognized as a diagonal elements. So combination of diagonal elements minus combination of other than diagonal elements is equal to 24. 6 4s are 24 minus 3 2s are 6 is equal to 18. This is the answer in case of two-dimensional matrix. Now in case of the three-dimensional matrix, A is equal to 312, 121, 102. So in this case, we have to go for the determine A is equal to 3 and remainings are 2102 minus 1 and remainings are 1112 plus 2 remainings are 1210. Okay, so first of all, we have to go for this 3 remainings are 2102 minus 1, so remainings are 1112. Similarly, plus 2 remainings are 1210, and this is two-dimensional matrix. So we know that 3 4 minus 0 minus 1 2 minus 1 plus 2 0 minus 2. Okay, combination of diagonal elements minus other than diagonal elements is equal to 12 minus 1 minus 4. 12 minus 1 minus 4 is equal to 7. So this is the determinant for the three-dimensional matrix. So dear students, I think this is the enough for today's discussion. We will meet on the next session for the further uh, title of the our syllabus. Thank you very much for listening me very silently. Thank you very much.